Welcome. If you saw my recent shorts, you would have seen me do these 3 castings. Now what this is a universal V-block system that I'm making for myself. The idea behind this is to be able to use it on all my machine surfaces, like on the table or my rotary table or on my angle plate. Now the reason for that is sometimes you need to do a long piece of tube and you need to work on the end, you need to drill a couple of holes in there, and in order to do so you need a V-block that's hanging off the side of the table. Now the milling head can move towards the side, so you can use the side edge of your table to do milling on top of a piece of tube. Now in order to make this work, I need 2 of these castings, 2 ends, with this block sitting in the middle in between. Now everything will be keyed, so there won't be even any movement between the top and the bottom halves of these the sides here. So yeah, in this video I'm gonna do the cleanup. Cleanup is quite a mission because this doesn't fit in my vise. So what I'm gonna do is I'm gonna remove the vise jaws in order to get this to fit. Hopefully that's enough clearance. If not, I'll have to do it in a lathe. But I prefer a fly cut machine surface. So I'm gonna see what I can do to get it inside my vise, even if it means I have to clamp it somehow in the middle here. Alright, hope you enjoy this one. By the way, it's not going to be a single video because there's way too much work on this. Okay, I'm starting off with a 1mm depth of cut from the surface here. I've touched off there. Now these 2 bosses are raised, so the cut is going to be heavier, up to 3mm, but the mill should handle it pretty fine because this fly cut of mine has a very low tool pressure on the milling head, so that I can take reasonably aggressive cuts with it in aluminium. Okay, I've got a little bit of inclusions left on this side here. So I'm going to take another 1mm pass off camera and then see what it looks like. Now that last cut was a 2mm depth of cut. And as you can see, it's handling it very nicely. Okay, took out off another 3mm. There's quite a bit of bubbling and inclusions on top, but it doesn't matter. This is not a mating surface, and it's gonna get marred up anyway with use. Right, so now I need to deburr the one edge and then flip it on its side and then start doing the second surface. Okay, I've got the spin on a movable jaw here because the surface is uneven. There's a little bit of a boss on the surface here on the bottom where the mold had a bit of a mishap there. It broke and pushed the sand out, so there's a section that's raised. Now that also caused the whole block to come out very skew, I only saw it afterwards because I knocked it down with a hammer and I forgot about that boss. Anyway, I'm going to touch off on this corner and then I'll drop down a millimeter. So that's going to give me about around 4 millimeter depth of cut. So I'm going to run the feed very slowly to stop overloading the tool. Let's see how it performs. I'm not dragging the tool or the parts while the tool is touching. I just drop it down until it touches, zero the DRO, lift it and then move the part out. Okay, that's my 1 millimeter depth of cut set. Now I'm using kerosene for a lubricant. Now kerosene is a very cost-effective way of lubricating your tools for aluminium and stainless. It also provides a little bit of cooling as well. Okay, I'm happy with that surface finish. There's a little bit of inclusions in there, but I'm not expecting this aluminium to be clean because using cans of all the paint and sand and everything that comes with the cans, it's difficult to get your aluminium nice and clean without having to go through multiple cycles of melting it down and casting and melting it again. So yeah, it takes around 10 minutes to do a single pass. So that's why I'm reasonably aggressive with the fly cutter, taking a formal depth of cut on this edge here saves me a bit of time. And the reason why I'm going for a fly cutter is because it gives me a very nice uniform finish. If you use a face mill or end mill, you will have machining marks that's reasonably visible, which a fly cutter doesn't do. So yeah, now I'm going to flip the parts 180 degrees so it will lay down on this edge here. I'll leave the back surface for last. Okay, there's a bump that I was talking about. So that messed up my whole machining efforts in the bottom side. But anyway, the block is going to be a little bit thinner, but it doesn't hurt. Right, so I'm going to take down a millimeter. There's a little bit of a low spot here, but it's on the side where the block should be on its highest. I just need to measure and see which side is the highest or the lowest and work from there. Alright, that's it's 55 mil. And with the attention, I haven't moved the caliper yet, so this is the low side. So I'm going to touch off from that corner there, which has got a low spot, and then take down a millimeter from that reference. Alright, this is going to be a very deep cut. It looks like it's going to be 4 to 5 mil deep on this end of it in order to clean up this corner. Busy with a bit of off-camera work here as well while the fly cutter was running, draining the oil of my lawnmower for its yearly service. So yeah, keeping busy while I'm waiting for the machine. I've turned the block on its end and it's too high for my fly cutter, so I have to resort to my face mill here. Now it's also going to have a formal depth of cut here, so I'm curious to see how it's going to perform. I haven't taken any of rough cuts like that on this little face mill before, so it will be interesting for me to see. Okay, that's the surface that face mill has left me, and as you can see on the heavier cuts it's cutting smoother than on the lighter cuts here. You can see tool marks on the lighter cuts, but overall the surface is fairly good. Now this is what the fly cutter does. So this end I'm going to do off camera and then bring you back. Now just something out of curiosity, if you look at this corner here, it would look like it's out of square because of the draft angle, but if you put your square to it, you can see it's 100%, so you can never trust your eyes. Okay, to remove my jaws from the vise in order to fit this part in here, and I've got it set on my engineer's parallels to lift it up so that I have the minimum amount of grip on the top Reason for that is when I turn the part around, then the sides is not going to influence the squareness of the part. I just want it nice and parallel, the two surfaces. The sides are running on a draft angle, and because of that you need to have the minimum amount of contact that you can get away with. I couldn't ask for a better surface finish. Now I've taken off more than I would have liked to take off, because this area here had a little bit of indentation that I needed to remove. Anyway, that it's no choice there, but overall surface finish is perfect, and there's not too much inclusions in this face here. Now there's a little bit of a sinkhole here, but that doesn't matter because I'm going to cut out the key here in the center where that square block or rectangular block is going to seat in, because that's going to be the spacer between the two sections. So I'm going to bring the other one up to the same point off camera, and then flip it and do the back side. That way I can ensure that I keep both parts 100% the same thickness. Okay, this is my last run, and then all the faces with the fly cutter will be cleaned up, and that is everything that I can do in a vise. That will be completed, and then the next step will be to set it up on a pallet table. I've got quite a mess to clean up here. Right, the parts are done, and They're looking good, even though the aluminium has got the small inclusions in it. Now everything that I needed to do in the vise has been done. So from here on in, I'll be moving over to the milling pallet. Now I've shown this inclusion here, or this the divots. There's nothing I can do about it. I don't want to thin it out too much. It's not a mating surface. Now this end here, it's going to be critical, and the two sides here. Now on these parts, once I've got it in a milling table or a pallet, I'm going to key it so that this block will fit in like so. Now at the bottom, I need to mill it first. Get it everything square, the two faces on top, bottom, on both of them. So on both of them, the sinkholes will disappear. And basically they're going to be keyed to this block. And the reason for that is I want to have a nice standoff between the two, which will give me a reasonable amount of torque and height lift on this on the V blocks, so that my coil can reach without any issue. So yeah, that will be all be done in the next video. I know fly cutting entire video is not very exciting, but it's part of the process of machining, and cleanup needs to be done in order to do all the intricate little bits of work. So yeah, hopefully I'll see you in the next video. Until next time, cheers.